Hi students, very good morning to all of you, and this is R Vivekanandan welcoming you all to this wonderful channel. Let's crack GATE and ESE Mechanical Engineering. And as you all know, we are having a series of classes and lectures on welding, and today it's a welding part 3 class where we are going to discuss about the welding terminologies. And to inform you right away that tomorrow we have a class at 10:30 a.m. tomorrow sharp at 10:30 a.m. on the gas welding and its types. Sir, this might take a time to complete, so please make yourself available for at least 1 hour plus. Okay, I want to complete each and every point on the gas welding in the same session tomorrow at 10:30 a.m. Please make a note of it, and I request all my students to give a message in the chat box and make your presence felt. So we all know that in the first class we discussed about what is welding, the definition of welding, the types of welding, and etc. Correct? Types of welding, etc. In the second session, part 2, we did discuss a lot on the welding techniques, the weld positions, followed by the weld joints, where the joints to be made. So these were the topics that we have discussed in the previous 2 classes. So just to show you the overview of it, I have the slides which was already that we have written has been saved here. So for your kind information. So welding part 3. Am I audible? Just let me check myself if I'm all completely okay. Okay, everything is all good. So let me come back to the segment. So students, it's an important information to all of you that I'm R Vivekanandan with 9 years of teaching experience, GATE and 3 times with a plus verified educator in Unacademy. I have cleared even the Indian Overseas Bank employee exam, like through IBPS. I was a former Indian Overseas Bank employee, and an Air Force exams I have cleared in the TRB Polytechnic lecture. This is all about the technical side, a lecturer for the government college for the mechanical side. So I've cleared these examinations. I do have 3 Indian patents in the manufacturing side. I have prepared, I have manufactured a particular product which is something new in the market. So because of it, innovation has got published, waiting for the granting from our intellectual property team. So the free classes, if you want to watch mine, it's curated by the India's top educator. Okay, you can scan the QR code to watch now, or the link is link is available in the description below. So final call to buy the GATE printed notes till August 31st is here. Not sure about the look at this. You can use the code VivekGate20 to buy the printed books. Okay, and here about the Unacademy Lite, students, test series and printed notes for GATE and ESE Mechanical and Chemical, 16 printed books with over 4,800 pages in the 2 trenches, curated by the top educators, 60 plus topics, subject wise and full length mock test with video solutions, chapter wise practice questions and solved examples, available from 10,942 rupees. Okay, so you can have a good look into this. You can again use my code VivekGate20. So you get not only the printed books but also the test series which is available in our app. Okay, but please make note, books are not available for the ESE exams and chemical branches. Okay. And GATE and ESE comment, looking at it, you can understand. Today, right at 11 a.m. So you once you complete this class, you might get an idea that today 11 a.m. you have this test. Please attend this GATE and ESE combat test. You can attend it in the Android app and the web as well. It's a live test, my dear students. For the rank holders in the each department, say you are from mechanical, right? In mechanical, up to 150 ranks, you get such scholarships, which is way ahead of the regular offers that is provided in Unacademy. So please do attend the 20 questions in 60 minutes of time. From all the mechanical based subjects, you will get questions. Even from aptitude, you can expect a question. So students, even now what I am teaching in the welding will be available for you over there in the form of manufacturing. Please take a good look into this. Okay? Please take a good look into this, my dear people. It is very, very, very important. And yes, your GATE and ESE, we all know that it's less than 6 months away, your GATE 2023. So begin your preparation with the Unacademy iconic subscription at 3,104 per month. You have the exclusive test series specially, and printed notes will be definitely a part of your subscription, and one-on-one live mentorship program is the huge bonus. An iconic subscription student will be availing over the regular plus subscriber, and customized doubt solving sessions will be also available. And subscribe now for the same using the code Vivek GATE 20. You can see here, we the 12 people who handle the classes in Unacademy for the mechanical department. So the wonderful Praveen Kulkarni sir, S.K. Mundal sir, Marut Tiwari sir, J.S. Gill sir, and Rajiv Singh sir, myself Vivekanandan R, Satyamurthy sir, Saurabh sir, Uma Maheshwar sir, Saurabh Thakur, Aman Raj, Shreya C. We all are handling the classes for the mechanical engineering students, and this is the batch Ummeed for the 2023, where from September 1 bilingual, the strength of materials classes will be started by J.S. Gill sir, followed by metal cutting by S.K. Mundal sir. You can see the timings. So students, you can definitely pitch in so strong with your content if you get the content, like knowledge from these educators, from us. So you can do one thing, you can use my code VivekGate20 to avail the discounts over your fees. Don't hesitate, guys. Now at the same time I can speak in Tamil, I can speak in English, I can understand Hindi, and I can convey back in English. Okay. And if you are looking for, sir, only I need, I need an EMI options there to pay my monthly subscription amount, then you can go for no cost EMI, where you can avail loan, and that can be approved in just 2 hours with minimum paperwork. Okay, flexible tenures is another one important point. Please make a note of it. So terms and conditions are there on the platform, which you can know through the number 8585. But when you are looking for a loan, inform them to use the code VivekGate20, avail the discounts. So going back to the content, these are the topics that we have completed. In the previous class I said, and you can see here, 2 1 marks, or 1 1 mark and 1 2 mark, or 1 2 mark, or 2 1 mark and 1 2 mark. So you can easily expect a 4 marks from this. And the new 2 mark questions will be always a numerical one. We have given the definition, what it means. Sir, this is written in the previous class. For all your information, please make a note of it. Okay, please make a note of it. So about the welding, we have just got this idea, right? What is meant by welding? So welding is a metal joining process which produces the localized coalescence of materials by heating them to a suitable temperature with or without the application of pressure, or by the application of pressure alone and with or without the use of filler material. Students, so joining is all about heating the material with the filler material or without the filler material. If it is with the filler material, if you are doing the heating operation to join, it can be with pressure or without pressure. And without filler material, you can apply with pressure or without pressure, just purely heating, or just the pressure only. That is what the above statement is all about, that I have just broken down and presented here. Maybe this would be really helpful for you guys. Hello Karthikeyan, vanakkam. Sorry நீங்க எப்போ மெசேஜ் பண்ணீங்கன்னு தெரியல. But still if you are looking into the session, தயவு செஞ்சு கனெக்ட் பண்ணுங்க எனக்கு. If you are still there in the session, எனக்கு ஒரு டெக்ஸ்ட் பண்ணுங்க. நான் உங்களுக்கு சில இன்புட்ஸ் ஷேர் பண்ணுறேன். So for sound welding and the best welding, my dear people, you have to understand these are some interview based questions, simple questions. If you want to know, this is the material which is welded, two joint materials, which are welded. After welding, if you are loading the material, upon loading, the fracture should take place at a point other than the welded joint. It should not break here, not here. Okay, it should not crack here, but at other points. Correct? It should happen at other points. Am I right? So this is an important note my students needs to understand. Please make a good note of it. So these points we have already discussed. So advantages and limitations. One point alone I have to reiterate here. That would be, we say that permanent joining is an important advantage of welding. But the same permanent joining becomes a limitation because during repairing and maintenance, you have to, break down the permanent joint positions for repairing. Right? So that is the only place where it becomes a problem. So kindly make a note of it. So while looking into the chat box through my mobile phone, so please do let me know if you have a message to convey. I'm glad to reply you back. Students, so the applications and everything is done. So here we can see the welding types, the solid state welding, liquid state welding, and the solid and liquid state welding. Under the solid state welding, we know that it is the parent materials are not melted, but in the same solid state the welding takes place. Right? The welding takes place. So joining takes place, where you have the classification of pressure welding, friction welding, explosive welding, ultrasonic welding, diffusion welding, forge welding. And in the liquid state welding, you know that there are many classifications. It stands for the material, the two materials which are supposed to be joined are taken to their liquid state. That is, the heat produced is able to melt the material. Operating temperature is above the melting point. All these words we can include to define the liquid state here. So liquid state welding are majorly classified into chemical and electrical. In electric type, we have arc welding and resistance welding, and you have the subclassifications. And in chemical, you have gas welding and thermite welding. In glass welding, you have the subclassifications. So this liquid state could be a autogenous welding with no filler material being used, or homogeneous welding with the filler material, that is same as the parent material, or heterogeneous where it is the filler materials that are different from the parent materials. These cases are while alloying. You want to include the filler material becomes the alloying element. Right? This is where it becomes. So kindly make a note of this point, these points also. So why I am giving a recap here is because students who are attending the class for the first time, I want to share this. Good morning, Rupesh. Okay, that such classes has happened earlier. But this is okay. Giving a recap is always good for my students. I always consider my students their benefits. What they get from me is very important. Giving a recap is totally fine. That's what I would say here. Okay, totally that is fine. Please make a note. Okay, so about the solid state and solid and liquid state, it's an interesting factor. I said solid and liquid, it's not solid or. Solid is where your parameters remains to be in the solid state, but your filler material which is used will be in the liquid state. And you can obviously say they are heterogeneous welding, where the filler material used will be different from the parent material. Only then the solid state of your parent material remains and your liquid state of your filler material could come in, because if they are same material, how come there could be a solid and liquid state established, right? And you can have the brazing, soldering and braze welding operations as well over there. So please make a note. solid state welding, you all just defined it here, and liquid state as well, and solid and liquid state. So coming back to the next point, so we have also discussed about the weld techniques, where you have the forehand and backhand, and weld positions, where we have four types: flat type, horizontal, vertical, overhead. In flat, you can do both forehand technique as well as backhand technique. Here there is a shortcut to say it should be backhand technique, because it will not disturb your line of welding. Okay, you know where exactly the welding has to be done. That is only possible through the backhand. Okay, where your flame comes first before your hand. Please make a note of it. Right? So that is an important line, my dear people. Hope everything is clear now for you guys. These points, right? So flat and forehand technique and backhand technique. This is a shortcut, HB pencil. Okay, we used to say 2HB, HB pencil. No, you can remember this, the backhand. When here it is remembers. Vertical is where it is forehand technique. You can remember the VFX effect, the graphics effect that we say, because the forehand technique will help you to make the molten metal, prevent the molten metal from falling. See, if you do the welding vertically, if I do it in this manner, this force from the arc will help the molten metal to remain over there, rather than doing it in this direction. Once you do it, you know that this welded area by molten metal which is available there will fall down, because the flame is already going up, the arc is going up. So that is a problem. So we are going for a forehand technique. And over is again where you go for the backhand technique. Okay, please take a good note of it. And the next one is your weld joints. So you know that we have the lap joint, butt joint, right? Fillet joint, T-joint, corner joint, edge, and so, right? So now, as we know, the title is all about the welding terminologies, few terms that we all have to remember. Okay, understand. So those are the points that I wish to share with you people right away. Please have a good look into this content right now, guys. Right, great. So let's proceed to the next. Welding terminologies, are a lot of things are there. So let's put across each and every point in the systematic way. First thing our students should understand here is called as weld pool. Okay, we are calling it as weld pool here. So it is the amount of liquid metal. Okay, it is the amount of liquid metal available between the two parent material before joining. It is the amount of liquid metal available between the two parent material before joining. Okay, before joining. So we can express it in such a way so like this we are talking about. Okay, weld pool. So it generally happens in your gas and arc weldings. So liquid state welding is where this preferably we can say. Okay, so it is the amount of liquid metal available between the two. Okay, sir, that is all fine. When we talk about once it gets cooled down, what will happen? Okay, in other cases like in the resistance welding, we have these points to add. Even there, this is more interesting term. If you have any points, please do share your thoughts here, Pa. So the weld bead or the nugget that we say, especially this is in the resistance welding. We can particularly say this is for the gas and arc weldings. Okay, we are talking about it in the arc welding factors. So weld nugget, the amount of material which is added into the workpiece or parent material. The amount of material which is added into the workpiece. In single pass. Okay, in single pass we are talking about. So the word bead is generally what we say in the gas welding and arc welding. We can use the word as nugget in case of resistance welding. Look at the terms. This is how we interchange the word. Okay, we interchange the word. Kindly make a note. So next is even more an interesting factor. We are calling it as penetration. Penetration. So penetration, let us draw a diagram. It is the depth to which the filler material can be penetrated to the base material. Okay, it's not only that way or the arc itself that can be penetrated. So it's all about the penetration of the arc or the gas flame or the filler material itself we are talking about. So means it's a simple note why we are connecting with the filler material is because it is an additional material which is in the liquid state that can penetrate into the joints. Correct. So the depth to which, with reference to the filler material, we are defining it here. The depth to which the filler material can be penetrated into the base metal. So this is what we call it as the penetration. Okay, penetration. And few more points on the rest of the things we'll discuss. But if you have any doubts, kindly let me know. I'm just looking at the chat box. Okay, all good so far. Please do it. next is all about root gap. Okay, the root gap. It is the shortest distance between the two materials before joining, especially in cases of the uh, joint preparation when it is made. Okay. Especially in cases of your joint preparations. It is the shortest distance between the two parent material before joining. Before joining. Okay, before joining we say yeah. Okay, yes. More chat messages. No, fine. So I hope you guys are noting it down parallelly. Let's proceed to the next one. We are calling it as the toe. This especially happens in case of the fillet joints, the toe. So you can understand this through the diagram that I draw here. Okay, so here if you draw, right? So here you can call this two terms. There are two terms that I'm going to present here, which are the root as well as the toe here, both of them, excuse me. So root as well as the toe we are talking about. So root is here and the toe is here. So what is that? The junction between the parent material and the weld face. The junction between the parent material and the weld face. Okay, so let me write it here. Junction between the parent material and the weld face. Please make a note. Right, and it is the case in the fillet joints. It is the case in the fillet joints. Please make a note. And the next one is about the root. So one earlier that we have seen here is all about the root gap. Here is the root. It is the point of the deepest penetration in the fillet joint. It is the point of deepest penetration in the fillet joint. Okay, how deep it is. So you can see the deepest point, right? So this point to that front, how much from that you can say. So here it is all about the root. So you can see the difference between both the terms, right? From the toe to the root and everything. And one more point is about the throat. Throat is one another point from the same triangle we can introduce when they are like a fillet joint is being made. Okay. This is the two point. The shortest distance between the root and the weld face. Shortest You know that this is the weld face, and this is the root we are talking about. So from that point to this depth, we are calling it as. So additionally, these points are collectively from a gas or arc and everything, right? So I have to introduce these further points which we might come across in the welding, arc welding, but I want to connect it here as well. So I'm giving a new page for that, which we are calling it as crown. A very important diagram which we need to know here. So I don't have a specially special tools, so I have to go with the simplest hand sketch. And you know what, engineers should always be, a better engineers or the best engineers are the one who is able to perform in the least helpful conditions. They are able to show up. Okay. I don't think this is required here for now. It is all link would be the best option. Crown, let me bring it here. Okay, crown, let me say here what is the point. So here we have to particularly share the point. So this too. Here is how the crowning takes place, right? The welding would takes place like this. Right? So from until this point we are talking about. So this crowning. Can you see the point here? This crowning. So what is all about here? So you can understand these three terms are I'm reintroducing. One is a reintroducing point, like already we have discussed. What is this point, sir? We are calling it as a root gap during the joint preparation. What about this point? We are calling it as land. And what is this? We are calling it as crown. So the straight portion of the plate. This is the straight portion of the plate. This is the straight portion of the plate. I'm just painting it. Correct? The straight portion we are talking about. The straight portion of the plate provided at the bottom of bottommost point of the joint without any joint preparation, right? We are calling it as land. But we know what is meant by root gap otherwise. So root gap is already a point that we have discussed, right? Root gap is the point that we have already discussed. So it's a straight portion of the plate provided at the bottommost point of the joint without making any joint preparation, that we are calling it as the land. So we don't have any kind of a joint preparation over there. No V, no U, right? No J joint, nothing will be there. So in the non-favorable conditions, when you are able to present yourself with a freehand sketch, that's why the true engineer evolves, is what I used to hear from my professors in my college days. Because engineering drawing, we all go with our draft and everything, but even the drawing is all about for making the other person to understand, right? Without the language barrier, you can still convey the through the drawing what is your expectation. So that is the most important thing. So we have to always be ready for presenting it. So what is meant by crownings are then? So the excess material more than what is required. So you can see this. This is the line we are expecting. So above this, all these material are excess. right? All these material becomes excess. The excess material provided over and above the surface of the plate. Excess material provided over and above the surface of the plate is called crown. Is called crown, my dear guys. Okay, so this is an important term which we all have to note down. So next comes your deposition rate and the number of electrodes as well. So some terminologies that I want to connect with you so far. Let me check the chat box if there is anything. I know you guys are slowly listening to this and making a good note of it. So crown with the root gap, I have just defined it. So next comes your, let me complete that point as well, so that the terms that I have noted it here. Number of passes, okay, number of passes that you need to know, and spatter as well, okay. How many number of electrodes that would be required, there is where this crowning term comes into picture. Okay, please make a note of it. The crowning term comes into picture when there is a term on the number of electrodes. Okay, so we will be using those terms. Please make a note in the upcoming classes. Now to the next heading, we are calling it as the deposition rate. Okay, deposition rates. This is actually in your kilogram per hour condition we are talking about. So the amount of material, like the melted parent or the filler material, whatever it could be. Okay, please underline this word. The amount of material which enters into the parent material. So here, when we say the amount of material, I said to underline. You know why? It could be the melted parent material or the filler material. It could be anyone. So amount of material which enters into the parent material per unit time. Again writing it per unit time. Okay, so it's more about a question in the numericals. You can expect this kind of a one. So please make a note of it. So it's all mentioned in terms of kilogram per hour, and this deposition rate has a lot of connection with your direct current straight polarity, direct current reverse polarity as well. Okay, between them this deposition rate plays a huge role, and that's where your non-consumable, consumable electrodes. So all these are getting interconnected now. How many number of passes will it be if welding speed will be high or low? Okay, high or low, and these factors. So for the non-consumable, the DCSP, the welding speed, and all the deposition rate, these are well connected between them, my dear guys. So have a good note of this, and again an information that I want to share with you people. I hope it is clear to all of you in this regard. Make a note. Okay, so the deposition rate, and the next comes your flux. Flux. So next is your flux form. Flux and filler materials, we try to complete it. So flux it is commonly used to deoxidize the material. No, to deoxidize the material, especially in case of your gas weldings, and prevent it from get oxidizing. Okay, and the flux helps in forming the slag over the weld bead. So you can see the word what I have used, bead, that is all for your arc and gas weldings. Remember the term. And it also absorbs the gases. The gases. So that's how the deoxidation takes place. If you're not, how it can be done, right? So this is how the deoxidation takes place. The commonly used flux materials are the sodium tetraborate. There are a few more, but let us understand the sodium tetraborate, commonly called as borax. This is the flux material majorly used. Okay. The melting point of the flux should be always less than the melting point of the parent material. Only then the flux can easily protrude into the weld pool and prevent the material from oxidizing, right? And also the density of the flux should be less than the density of the parent material here. Please take a good note of it, the parent material. Okay, it should be less here as well. Students, please have a good note of it. Any messages here, most welcome. I would like to hear from you people and clarify the doubts of yours accordingly. So just giving you a minute of time to note down these points, and then we can proceed further accordingly. Okay, so about the gas welding, and we have one more point on the torch angle also to complete. So those are the points I would like to complete prior to ourselves getting into the gas welding topic. So please make a good note of it, guys. And we'll move on to the flux filler material right away. Okay, filler material. So the filler material is all about the addition of the material. It could be same as a parent material or different from the parent material. But especially look at the condition why filler materials are generally used. Okay, why they are used. For this reason. And here. What you can see here, joint preparations have been made here. Can you see? The joint preparation has been made. So what I would like to share here is, my dear guys, okay, the addition of material which could be, see, the material is already removed from this place, correct? Material is removed. Now, if you are trying to weld the material by gas or arc, whatever, right, between these two, the material will melt and it will be depositing here, correct? So what about this area? It is unfilled. To fill the unfilled area, correct? To fill the unfilled area, we use filler materials, correct? So the gap cannot be filled because there is no metal to fill. Sir, if this is the case of these two materials to be joined, now if you melt it, this again sits over there. So the sufficient material will be available over there because there is no cut has been taken place. But since the material has been cut in an order, so the cut is also required in many occasions because the strength will be more. Okay, the strength will be more particularly over there. So when there is a joint preparation made, especially, okay, to fill the unfilled area because of lack of material available at the production, filler materials are used. So the addition of the material, addition of the material that could be either same as the parent material or different from the parent material, it could be, to fill the gap. Fill the gap, my dear friends. This is where the filler materials are being used. So it could be if, like, two steels are getting welded to be joined with a special joint over there. If I want to use a filler material, the filler material can be same as the steel, the same composition, the same alloy, like, same composition of the steel. It could be, or it could be any other material that I subject to add as an alloying element. So the joint could become even more stronger. So any properties that I want to improve over the joints, I can do it by adding the different material as a filler material over there, right? So this I wish to convey to you people. Please make a note of it. Good morning, sir. Good morning. Right? So the density of filler material is less than, or it could be equal to density, because the equal to sign is because of the parent material. If it is same as the filler material, then this condition comes into picture. In the previous case, we are not doing it because the flux will be always, it tends to be of a lesser density and of lesser melting point as well. So the melting point of the filler material is less than or equal to the melting point of the parent material. Okay, students, please make a note of this. So next class will be even more beautiful, I can assure you. Okay, it will be even more beautiful, I can assure you. So just giving a quick recap of what are the terms that we have discussed here from the Weld Pool. I have the last torch angle to discuss before we conclude for the day. Students, once again I want to inform you that tomorrow we have a session at 10:30 a.m. where I will be completing the gas welding. Right, from what is gas welding, what are the types, what is the different types of flames, why the flames have a different temperatures at different situations, what is the ratio of the oxygen to the oxygen over there, what impact does it cause in your welding, okay, and which is the most suitable type of gas welding that has been currently put into use, etc. All these in a complete notes I will be sharing it in the next session, that is tomorrow at 10:30 a.m. in the same YouTube channel. So please make a note of it right away as well. Right, Karthikeyan sir, Rupesh Maurya, PUBG as well. Okay, great. So we have discussed about the weld pool to the weld bead or nugget and penetration, root gap, toe, root, throat, crown, land, deposition rate, flux, filler material. Right, now proceed. Now moving on to the next is your torch angle. Very interesting one. Look at this. You can understand the definition of the torch angle from here. So the angle made by, it is the angle made by the axis of the torch and the angle made by the axis of the torch with the axis of the workpiece. Okay, with the axis of the workpiece. This is what we call as a torch angle. So, sir, if you're doing it in this direction or like this, can you see the difference? So this is what we say. So if this is the base of the workpiece and your torch is presented in this direction, you can see this is the angle. Right, this is the angle. Or if it is going up, the angle is even more. So please make a note. Angle made by the axis of the torch with the axis of the workpiece is called torch angle. So this is going to impact on the flame density. Okay, this indirectly hints you about the flame intensity for flame density. So what does mean by flame density? The amount of flame that is concentrating over the area to which the flame is exposed. Amount of flame to the area to which the flame is exposed. So this is what we call it as the torch angle here. Clear? This is what we call it as the torch angle. Please make a good note of it. Hope you guys are noting it down. So what is the difference there? So torch angle is going to impact on the flame density. That's what I want to share here. Let me give a different color to discuss the same. If this is the top view, okay, for the given area, the same area, is it this dot or this spread? It all depends on the torch angle. Okay, this is what it is. So more area of exposure, less area, correct? So when this is the case of torch angle is, how it will be? Is high, but here the torch angle is less. So more the area can be exposed for the welding or heating, we say. But when you are concentrating with almost 90 degree, it is just a point. But that is also useful in some occasion. That's what we are going to discuss through this torch angle. The impact of it. Okay, the impact of it. So during the starting of the welding, especially, you can go for more, less torch angle from the start and just before the end. There is a deeper meaning in it, because when you start to weld here in the lesser way, here it spreads a lot, but when it reaches the end point, my dear guys, when it reaches the end point, okay, you can't do it in the same direction, because the molten material may be forced to go away. Molten material, getting the idea? Forced away due to the less torch angle. Why is a less torch angle is causing it? Because the force of that flame, gas flame or the arc, right, will make the molten metal to be thrown out. But so at that particular junction, you have to maintain a high torch angle, thereby just melting it. So you go from here to here almost with a low torch angle, but at the end you have to make it like this so that the molten metal will not be thrown away. So this is the most important line behind the point. So please make a good note of it. Right, my dear students? I believe it is loud and clear to you all. Right, so there are three occasions of the torch angle that has to be related with talking about the thickness of the workpiece. If you have a better thickness of the workpiece, and in the situation of the melting point of the workpiece, in the other case of thermal conductivity of the workpiece. Okay, thermal conductivity of the workpiece. So when your thickness of the workpiece keeps on increasing, I have to weld the material. Sir, I mean the penetration demanded is higher. If I say to this penetration, what you have to do? You have to narrow it down to that junction, right? So that the welding will be having a better penetration over there. So you need better penetration. How the torch angle should be? For the better penetration, how the torch angle should be? The torch angle should be higher. So lower the penetration required, you can have a maintain a low torch angle, but higher the penetration or the higher the thickness of the workpiece which are to be joined, definitely the higher torch angle is to be maintained over there. Talking about the melting point of the workpiece, say a 500 degree Celsius material to a 1000 degree Celsius material, you have to focus a lot of flame onto that particular junction for the welding to take place quicker. So it means if the melting point is keep on increasing, definitely the torch angle also to be increasing. And in the third case, it is about the thermal conductivity of the workpiece, right? Thermal conductivity of the workpiece, my dear guys. It is to be noted, if the thermal conductivity is keep on increasing, means if the thermal conductivity is higher, definitely you have to expose more of the flame or the arc. So you have to maintain a high torch angle as well. So please make a note of this as well, my dear students. It is very, very, very important. Okay, it is very, very important. It's the important line I want to share it here. Great. So these are the two classes that we are supposed to complete here, torch angle as well. So students, hope you all got the clarity. Because, sir, can you explain it here, the thermal conductivity? Sir, we know that if you are heating the material in this direction, like with a low torch angle, if the material is able to conduct away 50 degrees Celsius per second, and if you maintain it in this high torch angle, the supply of heat to that point will be more, so the concentration is higher, so it can easily get melted comparatively, right? So the heat conducted away to the heat supplied, if you are improvising on the heat supply, definitely the melting will take place quicker. So more time will be there required for less torch angle. If low torch angle, more high welding time, right? Lengthier welding time we can say. So this is why, to overcome the burden of welding it for a long time, thereby the power consumption increase, the total cost of the joining would get increased. To improvise on that, we go for such improvising in the parameters to get a sound welding and also an economical welding as well. So the conclusion over the torch angle is that theta, your torch angle is proportional to your melting point. Theta is proportional to your thickness of the workpiece. Theta is proportional to the conductivity of the workpiece as well. So it's increases as well. Okay, so these are the points my students have to note down when it comes to the welding terminologies as well here. Kindly make a good note of it, and we have to proceed to the other terms. So we have done with the basics of the welding terminologies here. So about the efficiency and the other stuffs, we can discuss it in the upcoming class. Okay, so the gas welding, everything will be discussed in the upcoming class. So just to inform you that again, so the upcoming class is all about gas welding part, to discuss about the types and everything. Also, if we are completing, we will continue with the resistance welding instead of arc welding, because that topic we can conclude at the earliest as well. So we all know these two comes under the category of liquid state welding. right? It comes under the category of liquid state welding. So we'll be completing these terms for your information. Okay, so have a good note of it as well. Yes, we will be discussing them in the next class. That is tomorrow at 10:30 a.m. It will be a session, quite lengthier session. So more than 1.5 hours we'll be discussing that. So looking forward to have you all in that wonderful course. Do join, guys. Thank you. Have a great day with your family and friends, and thank you for joining here. Students, don't forget to use this code VivekGate20 for availing the maximum discount, and to put with a word about the printed notes and the distance learning. If you have a plan on that instead of a subscription, here it is. This one. So 16 printed books with over 4,800 pages in the two trenches and curated by the top educators, 60 plus topics, subject wise and full length mock test with video solutions, chapter wise practice questions and solved examples are available just from the 10,942 rupees. You can use the code for the same to get the maximum discount. And this is all about the Unacademy Light Distance Learning Program. Okay, the printed books plus the test series is what we are receiving through this subscription. It's a value for money. You can get all the help from us in the free classes as well. So you can start watching my free classes, my dear students. Don't forget to enroll for the same. Okay, because my free classes you can watch through this scan of the QR code or in the link in the description below that you can see my classes. So I'm welcoming you all for my upcoming classes in the Unacademy Plus, special classes and the plus classes by subscribing, and the gas welding and the resistance welding topic will be discussed in a more beautiful manner in tomorrow's session at 10:30 a.m. Right, students? Looking forward to have you all. And today, like almost we have 5 more minutes to start the test. So don't forget, please do enroll now. Okay, please do enroll now and get the benefit of it. If you like the session, you can comment in the chat box and share your thoughts, and share this particular video with your friends for them to note down the important points, so that helps them in their GATE preparation as well. So do join for tomorrow's session. Thank you. Lots of pages we have written. So subscribe to the channel and click on the bell icon as well. Thank you, my dear people.